We just have one more example, but I wanted to start with my optimization steps. So here they are, kind of like the related rate steps. You may find, these problems can get so long you might get lost in where you are, and so having some checkpoints so you can orient yourself is nice. Step number one, make that drawing. The drawing cannot be uh, underestimated. A good drawing can, will really, really help, especially in the harder questions, to get you to those equations where, a drawing that's incomplete or is maybe done kind of sloppily and fast is not going to be nearly as helpful, or might even lead you down the wrong path even. Okay, so take your time with the drawing. Also, the drawing, it just sort of allows you to sit in the question after you've read it and sort of reflect on all the parts and how they're connected. So you don't just have to dive in right into equations and solving and derivatives. Having a few seconds or several seconds to make that drawing, kind of wrap your head around the question, is huge. Okay, then number two, find two equations to describe the problem. Every optimization question is going to have these two equations: the one you're trying to optimize, and then your constraint. And keep in mind the constraint's always going to be equal to some number told you in the problem. Step three, write what is to be optimized in terms of one variable. So we always use the constraint to solve for one of the variables so that we can plug in to our optimizing equation. Typically, one of those variables is much, much easier to isolate than the other. So when you do the constraint, usually one of them is going to pop out to you as being a whole lot easier to solve for than the other one. So go with that. Do the easy one. Then number four, write the domain of that variable. So whatever variable you use to write your optimizing equation, you got to think through, okay, what's the smallest that it could be? What's the biggest that it could be? A lot of that can be a very challenging step. There's not a lot of computation, but there's a whole lot of thinking. Well, we're going to see another example really soon. And then number five, find the absolute max or min, whichever one they're asking for. Then you've got your function, you've got your interval, your domain, and you can go ahead and proceed with the absolute max and min steps. But of course, we're only looking for one. Are we trying to maximize or are we trying to minimize? All right, here comes our second example. You're going to see one or two homework questions of this nature. It says find the point or points on this curve y equals 4 minus x squared that is or are closest to the point 0, 2. Okay, this is, it seems kind of like theoretical and, kind of abstract, but this could be hugely important for some of the fields that some of you guys go into. Can we find the closest point or points on that curve to this one point? Okay, so, we need to start with the drawing, right? What's our drawing going to be here? It's simply going to be that curve, and then we're going to indicate that point as well. So if you want to take advantage of Desmos for a question like this, I think that's wonderful. But maybe you know what y equals 4 minus x squared basically looks like. Well, it's a parabola, it's facing down, and it's been shifted up at 4. So it looks like negative x squared and then adding 4 to it, something like that. We'll also indicate the point 0, 2 right there. So it's halfway up from the x-axis to that vertex. Now we want to draw a little bit more than this. This is great to get started, but the question says find the point or points on that curve that are closest to 0, 2. And so we would think, okay, well, somewhere along the curve, there'll be a point that's closest to this one. So you think, all right, it's probably not straight out. it's probably angled up a little bit, right? And it's difficult to say how much, but up there. So that's probably it. And I'm going to label that x comma y. So the goal here is to find the point xy that's closest to 0, 2. And we can also see, because of the symmetry, there's going to be another point over here the same distance over there. Now here's the thing. I'm not going to bother labeling this point, because if I find this one, I will immediately know this one, right? It's got the same y value, but the negative x value. So I'm just going to focus here on the positive side, and then I'll know to find the other point, just take the negative x coordinate, and I got that other point. So I can really just focus on this only, which makes things a lot simpler. Okay, so we've got a good drawing here. What are the equations going to be? Okay, it's all about, it doesn't say the word, but it's all about distance, right? We want the closest that we can be. We want to minimize the distance. So let me write that. Slide this up. Minimize the distance from xy to 0, 2. This is what we're trying to optimize, in this case minimize.